In this video, we're going to see an example of how to find an x value given an area in a problem that is normally distributed. So in this problem, we have the birth weight of newborn babies is normally distributed with a mean of 7.5 pounds and a standard deviation of 0.6 pounds. A baby in the bottom 7% must be monitored to make sure they are gaining weight. What would a newborn have to weigh in order to be monitored? So the first thing I'm going to do in this example is jot down what we're given in the problem. So we do know that the mean weight is 7.5 pounds, and we're given a standard deviation of 0.6 pounds. And then we need to recognize what we're given, right? In the problem, we're either going to be given an x value that we're going to eventually convert into a probability or an area, or we must be given an area that we're going to go backwards and convert back into an x value. So I'm going to underline right here a baby in the bottom 7%. Okay, so 7% automatically to me is a probability, is an area. So when I draw my normal curve, I don't have an x value or a z-score to label. What I do have is an area to label. So I'm going to shade the bottom 7%. So I'm going to go to the left because that word bottom. And notice I'm not putting a label here at the bottom of this for a z-score. I'm putting an area, I'm shading to the left and labeling that area. So this area right here as a decimal, if it's 7%, that's going to be a 0.07. And we are trying to find this z-score that has 7% of the area to the left. So as we saw in class, there's different ways we could do that. We could use our table, our green table, and look for an area of 0.07. So we would be searching the whole middle part of the table for an exact 0.07, which is hard to find. And we can't always find that exact value. Remember, our other option that we did in class was to go to inverse norm. This one's perfect for inverse norm. We don't have to worry about changing any signs, using any complements, because this is exactly how the calculator wants it. It wants the left-hand area of 0.07. And remember, we're leaving mu and sigma alone. And the z-score that I get out should be negative, because if we're at the bottom 7%, we're definitely well below the mean. So to 2 decimal places, I have a negative 1.48. I have a negative 1.48 as my z-score. We can give more places. We won't give any less than that, but that's my z-score. So that's what this is right here. That kind of fits well with what we said about the empirical rule being 2 standard deviations out and how much area is left in the tails then. So my next step is to so far we've taken our area, we've converted it back into a z-score, and our last thing is to convert that into an x value. So we have the formula that we wrote in class, but even easier to maybe think about is just to think that we need to be, in order to be in the bottom 7%, we need to be 1.48 standard deviations below the mean. I have to be below the mean, which is why my z-score came out to be negative. So if you think about this and think about this wording, I have to be 1.48 of my standard deviations below the mean. And that's the exact formula that we wrote for converting a z-score into an x value, because that's our mu, and it can be plus or minus depending on our z. Our z was negative here, but that is the formula that we wrote for x in our notes. But if you think about it with this underlined piece and phrase that I wrote right there, 1.48 standard deviations below the mean, then you've got that formula right there. So let's see how this comes out. In the problem, we're saying we're round to the nearest tenth. So let me just do a quick calculation. You do it as well. And let's see what we get. So I have unrounded about 6.612. So because we want to round to the nearest tenth of a pound, I'm going to go down to 6.6, or I'm not going to round up, I should say. I'm going to keep it at 6.6 for a couple reasons. Even if it was this one right here, was above 0.5 or above, I would still round down because I'm trying to figure out how much would the baby have to weigh to be in the bottom 7%. And if I round it up to 6.7, then that baby is not quite in the bottom 7% anymore. So we're going to say the baby would have to weigh 6.6 pounds in order to have to be monitored. So that was an example of taking our area in the beginning, our 7%, converting it to a Z, and then converting that to an X value.